everyone, and welcome back to a little review of Algebra 1 with some radicals. Now, reminder, the symbol that we usually use is a square root symbol. Looks like this. Now, there's a little imaginary 2 there because we are taking the square root, undoing a squared number. But there officially are other roots you could take. We just won't focus on them in this lesson. Now, sometimes there are perfect squares, and if we look at this list here of perfect squares, just Google on the internet, these are all perfect squares because if we square root any of these numbers in this list, they come down to be, for instance, square root of 144 is 12. Okay, so those are our perfect squares. Now, some numbers, though, aren't going to break down to be so nice. For instance, the square root of 54. So you think of some factors that multiply to be 54, for instance, 2 times 27, and keep breaking down any of these numbers that have more factors to see if any of them have a perfect match that they can move out of the radical with, right? So they become a pair and come out as just one singular 3. Anything left over gets multiplied together underneath the radical and becomes our final answer. Okay, so you always want to look for a list of perfect squares if possible. So for instance, we have the square root of 16, which is just 4, square root of 81, which is just 9. So we have those both there. Now, again, we have plenty, though, that don't have a perfect square necessarily, like 24. So we think of things that multiply to be 24. There is a perfect square that multiplies with another number to be 24, and that is 4. 4 times 6 does multiply to be 24. 4 then again is a perfect square for 2. 6, even though it breaks down to be 2 times 3, and those aren't a perfect match. They have to stay underneath the house. So we end up with a pair of 2s that did move out, and then 2 and 3 become square root 6. Same thing with 12. 4 is a perfect square for 12. It's a factor 12, so 4 times 3. And again, we have that perfect square of 4 becomes 2 times 2. And we are left with then the 3. Now, don't forget on this particular one, there was already a 4 outside. So that's going to get multiplied by the 2 that moved out for a final answer of 8 square root 3. Last but not least, we have this big number here, 810. But if we look through our list of perfect squares, while there are a few that are factors of 810, a nice one is 81. Because 81 times 10 is 810. Breaks down to be 9 times 9. So that's a perfect square that moves out. And then again, with 10, even though it does break down to be 5 and 2, those aren't going to find a buddy to move out with. So 9 square root 10 ends up being our final answer. Now, what if you didn't notice, for instance, on this second one, that 4 was the perfect square that moved out there, and instead you said, oh, I saw this as 6 times 2. Well, 6 breaks down to, again, be 3 times 2, and then those are going to, again, be a perfect match that moves out, and the 3 was left over. So you still end up with that same answer of 8 square root 3 because of those being circled off. So again, you don't always have to find the perfect square that goes into it as a factor, but it sometimes can help make the process a little easier. Okay. Now, you try these next couple on your own and see what you get as your answers. Now, as we flip to page 2, we see some examples dealing with multiplying and dividing. So let's start with a multiplying example. So we're taking 4 square root 2 and 3 square root 3, and we're going to multiply those together. Now, our numbers that are outside of the radical are going to get multiplied together. Those become 12. And then the numbers underneath the radical are also going to get multiplied. That becomes 6. So 12 square root 6 is our final answer. And again, you always want to double check, can I break down the numbers underneath the radical anymore? In this case, the answer is no. We also have below a couple more examples. We'll get back to the dividing ones in a second with multiplication. Now notice here, there's a little thing happening where we have radicals that are the same number being multiplied. And what we're going to notice is anytime you multiply a radical by itself, it just becomes the number underneath the radical. Well, why is this? Well, we have the square root of 16. If we multiply those two together, that's just 4. Square root of 49 is 7. So it's kind of a little shortcut you can see happening that each time these numbers become just the number underneath the radical. Now this one, notice again there was a 4 out front. Square root of 2 times square root of 2 is just 2 for that final answer of 8. So as we try some of these examples down below, okay, again we have 2 and 6 on the outside. That becomes 12. And then we're going to multiply 3 times 5, which is 15. And so we end up with 12 square root 15 is our final answer. And you always want to double check, does the square root of 15 break down? But the 3 and the 5 aren't going to work into anything that is useful. Next one, we have 8 and then square root of 10 times 2. Square root of 2 is square root of 20. And we know from the first page that this is going to break down to be 4 times 5, and then 4 is a perfect square. So really this becomes 8 times 2 square root 5 for a final answer of 16 square root 5. Last but not least, just like we had on that first example, remember anytime you multiply a radical by itself, it just becomes the number underneath the radical. And then we also had a 4 and a 2 on the outside to begin with. So 4 times 2 is 8, times 2 again is 16. Now up above, we also had a division example. So square root of 10 divided by the square root of 2. Well, anytime you're dividing those two square roots, it's almost like you're able to divide them underneath the same square root. So 10 divided by 2 would just be square root 5, which doesn't break down at all. Oops. Square root of 5. So we see that on some of these other examples as well. When we have 16 square root 21 divided by 4 square root 3, we're going to divide this 16 and the 4. 16 divided by 4 is 4. And then 21 divided by 3 is 7, and that's going to stay underneath the square root. We also have the square root of 75 divided by the square root of 3, which again we've talked about could be rewritten as one radical. 75 divided by 3 is 25. Now the square root of 25 is a perfect square, and that one's just going to break down to be 5. Last but not least, we have 4 square root 2 divided by square root 2, cancels out. Anything divided by itself is 1, and then we are just left with that leftover 4. All right, next piece, all right, of simplifying is sometimes what happens when you have a square root in the denominator of a fraction. If it's in the numerator, we don't care so much, but in the denominator, we care a heck of a lot. So when we divide a number by a square root, and that's the final answer, we have to do something called rationalize, okay? And that means that we are going to multiply top and bottom of that fraction by itself, that number underneath the radical. The reason being, we talked about up above, that just becomes a nice pretty whole number. So what we do is we take 8 square root 2 divided by square root 2 and multiply top and bottom by square root 2, because we know that this bottom piece then just becomes a 2 when we simplify. So we end up with 8 square root 2 on the top divided by 2 on the bottom, and then the 8 and the 2 simplify to just be a 4. So in this first example here, we are going to multiply top and bottom by the square root of 2 to get that denominator to just be 2. Top is 6 square root 2. Now we're not fully done because the 6 and the 2 on this one do simplify, and it becomes 3 square root 2. Next one, we end up with multiplying top and bottom this time by square root 3, since that was the value on the bottom. And then we end up with 18 times square root 3. Again, we ask ourselves, are 18 and 3 divisible? 18 divided by 3 is 6 square root 3. Sometimes you're going to see that the number on top here is not divisible by the number on the bottom, and that's okay. You would just leave that as your final answer then if that does not happen. So if we look at the top of this last page here, you will see a couple more examples trying that out. So again, this last one here, that we see multiply top and bottom by square root 3, and we end up with 14 square root 3 on the top, and the bottom is just a 3. This is a great example where 14 and 3 are not divisible by each other, so we are just going to leave this as the final answer. Try the last two on your own, see what you get. All right, now putting this all together, we also want to be able to solve some of these equations, aka get x by itself, right? Find the value of x. So on this first example, you're solving, I want to get x by itself, so I'm going to divide both sides by 3. Well, what we're going to notice is that when we do that, there's a 3 that cancels out on both sides, and we end up with just getting x equals the square root of 11. Okay? Now, sometimes we're not going to be so lucky. Okay, like the example below it, when we divide over that square root 3, it does not just cancel away. In fact, what we notice happens is we get x equals 21 divided by the square root of 3. Well, we know from that last page and up above, we can't just leave that division by square root of 3. We need to rationalize. So multiply top and bottom by the square root of 3. We have 3 on the denominator, 21 square root 3 up top. And last but not least, 21 divided by 3 is 7. So there's our value of x finally. Now I'll back up top here. We get lucky again. Divide both sides by square root of 40. And the square roots canceled out. So that x just equaled 11 since the square roots canceled out. On the last one, though, we're not so lucky. Okay, we have to multiply both sides by the square root of 2 to get our answer of x by itself. Now, this isn't so bad because x is alone, and then we just have to take the square root of 11 times the square root of 2, which is just the square root of 22. 22 doesn't break down to have any perfect squares. If we look at our list of perfect squares, none of these numbers go into 22, so we don't have to worry about any of those perfect squares going in there. So just 2 times 11 there. All right, now this last section, again, we see kind of a miscellaneous mixture of these things. For instance, we see on letter A, we want to get x by itself by dividing by square root 2. Unfortunately, when we divide, we see that we can't leave our answer like this. We would have to rationalize to see what our final answer is to get a nice pretty whole number on the bottom, which is 2. That simplifies one more time because 25 is divisible by 2. This next one, though, for instance, example D, we get lucky, things cancel out, and we just get x equals 15. Last one in the first column, we have division by that square root, so if we multiply both sides by it, x equals 7 square root 3 times 2, which is just 7 square root 6. Okay. Try some of these last examples on your own, on your worksheet, and see what you get for each of them, and check your answers. Okay. Thank you everyone for watching, and we'll work more with these in class.